it's George, and I'm back again. And I have two interesting things to show. We're going to go to the TV set. Okay? And I want everybody to listen to what the person says, and then I'm going to pause it.
There are so many interesting targets in the area. Look at this pile of thin, flaky rocks. How did it get here?
Okay. Now, I've been finding a lot of rocks like this. And I'll show you. You get a good look at the picture, the thin pile, the weird shapes. Okay. And we're going to go to the rock. Thin rock. And this rock is green underneath the brown. But see how thin this is. Okay. There's another one that's green. It's a little bit thicker, but it's not as thin as this, but I found several of them like this. Okay, really thin. And if you look up here, you look how thin that is compared to those. This is from Mars, whether people want to believe it or not. It goes back to the temperature thing. I tried to explain to people that the temperature alters, the noctilucent clouds alter the temperature and the density in the atmosphere, the density of the air, which would cool rocks down faster and slow them down. But people refuse to want to believe it. And that's fine. Like I said, a person's got the right to believe it. Now, I got my Punisher shirt on because I'm going to punish the experts with what I found. I'm really going to punish them this time. Somebody, because of what I have found, somebody messed up because they didn't do the research. There are meteorites, there are meteors here on Earth, and there are debris fields. Now, whether you want to believe it or not, that's your choice. I got a very special rock that I found, and I did the research on it. Now, why is it still in rock form? Because it didn't get hot enough. I'm going to explain this, and we're going to see the rock. I call it the rock of creation. Sort of like creation at the beginning of time, because of the type of rock that it is. But it's a rock. Okay? Now we're going to go to it. Here we go. Okay? Get a good look at the outside of it and the color of it and the green and the white. Okay? But it looks like a rock. Okay? But when you go to the inside, get a close-up of that inside. Closer. Okay. Hold it right there for a second. Let people study it. Okay, back it up a little bit. Hold it right there. Let them study it. Okay. You see all this white in here? All this white. Okay? Now the white's going to be bigger because it didn't get hot and melt. Okay. What that is, that white stuff is calcium-rich aluminum inclusions. Now, why they're not small and a lot of the chondrites, which they're found in, why it's not small, because it didn't get heated, it didn't melt down to like the regular size when you find the small bits and pieces and fragments. Now, how do I know this is a carbonaceous chondrite? Because CIAs are found in that. Now, there's a whole list of other things, and I'm not even sure how to produce the names on some of them. The elements and the minerals and everything that's in there was big enough I can see it with the magnifying glass. Every single one of them. Every single one of them. I looked them up. I looked at pictures. I went and looked at it. Every single one of them. Okay, so what is CIA and the Forsyth-rich olivine and the calcium, whatever you want to, and the hibonite and all that other stuff that's in the carbonaceous chondrite, what is it doing in the regular earth rock? This is the problem that I have. And the thing that I told people about, the temperature altering. Okay? These, with the CIA and all these elements in it, they consist of high temperature minerals. That means they require a high temperature to even convert and melt. Now, the green in it, we'll go back to the rock. We'll go back to the rock and look at it. A lot of this green and a lot of the different colors and the black in it and everything, there's a lot of green olivine in this. And this would be similar to the color of the Allendale meteorite. But like I said, people aren't going to want to, they're not going to want to believe it. They're not going to want to believe it. They're going to call me stupid. They're going to call me an idiot. But I'm telling you, I've done the research. I've looked this stuff up. And I've never seen a rock, broke open a rock that has that much white in it. And it's white. It's not crystals. So, with that being said, I feel I don't need to make any more videos. I feel that I proved my point. The only thing I need to do is test, and I guess I'm going to have to get some money up to go have some testing done on this stuff, because it's got to be tested. You can't tell by looking at a picture. You can't tell by looking at this if it's what I say it is, because everything on the inside didn't get a chance to melt down. The olivine didn't get a chance to crystallize. Olivine has to get heated to crystallize and be all shiny, in case people don't understand this. And it's the same way with other stuff that's in here. If it doesn't heat up, it doesn't shine. And that's all I'm going to say.